All right, so today we're learning the elimination method. It's a different method than substitution, except you use part of substitution for this. Berkeley, can you see all the things?
Yeah, you can see everything.
So what you do is you make either the x's or the y's opposites, if you need to. You add the equation, solve for x or y, then substitute that answer into one of the equations to find the other variable, which we've done before in substitution. So it's like half substitution and like half of a new method. Okay? So when I say add the equations and make opposites, here's what I mean by that. If I look at number 1 here, I notice that I've got a positive 3y and a negative 3y. Those are opposites. When I add them together, they equal 0, right?
Mm-hmm. Yeah.
Okay? So that's what I'm going to do. I'm now going to add these together so that this will be zeroed out, okay? So, that's the first thing I look for, and I look to see if either the x's or the y's are already opposites, and they are in this case, okay? So if I add them together, this equals 0, of course, right? Then x plus negative 3x is going to be negative 2x. 1 plus negative 15 is going to be negative 14. Now I really don't need that 0 there, so I'll rewrite it as negative 2x equals negative 14. So now all I do is I divide through by negative 2. And so x then equals 7. Pretty easy?
Yeah.
Yeah. Now here's where the substitution comes back in. So now that I know that x is 7, I'm going to substitute it back into either of these equations to get the other answer. All right?
Mm-hmm.
So I'm going to take 7. I'm going to choose whatever is easiest. I'll just do the top one. So I'm going to take 7 and put it for x. So then I have 7 plus 3y equals 1. So then I need to move 7 over. So I've got minus 7 on both sides. And then 3y equals negative 6. Divide through by 3. Then y equals negative 2. So my whole solution then is 7 comma negative 2. And if you recall, we're solving a system of equations, so the whole purpose of this is to find out where these two lines cross each other on the coordinate plane. And that point is 7, negative 2. Let me spread that a little bit clearer. Okay? Okay, now, the first step says make either x or y opposites. Sometimes they're not already opposites.
Mm-hmm.
So you have to make them opposites,
Mm-hmm.
okay? So what I'm going to do here is the easiest one to do is the 2y, because they're both 2, but one of them needs to be negative 2y. In order to get them to be opposites, what do I need to multiply this by?
Oh,
Negative 1.
negative 1.
Right, because I want this one to be positive, I want this one to be negative, or vice versa, when this could be negative and this could be positive.
Oh, yeah.
Yeah.
What about
No, you're fine. I'm just asking. So what I'm going to do is I'm going to choose one of them to end up being negative, okay? And what I have to do is I have to multiply the entire equation by negative 1. And what I mean by the entire equation is each term. So negative 1 goes times 8x, negative 1 times 2y, negative 1 times 30, okay? And so what I end up with then is negative 1 times 8x is going to be negative 8x. Negative 1 times 2y is going to be negative 2y. Negative 1 times 30 is negative 30. Now, to make it easier to look at, I'm going to move this down. So, then we have 7x plus 2y equals 24. I put it below here, but you can put it above too, it doesn't matter. So, now, our next step, step 2, is to add them together. So I have negative 8x plus 7x, what's that?
Oh, that's negative 1x.
Right, negative 1x. And And I've got, then this zeroes out, right? So negative 2 plus 2 is 0. And then I have negative 30 plus 24 is going to be negative 6. Divide through by negative 1. And then x will equal positive 6 because negative 6 divided by negative 1 is going to be positive 6. And that is the first half of our solution. Now, here comes the substitution. I need to substitute this 6 back into one of my equations and solve for it. Okay? I'll just put it in the top one. So then I have 7 times 6 plus 2y equals 24. Okay? 7 times 6 is 42. Plus 2y equals 24. So I'm going to subtract 42 from both sides. Okay? Then I end up with 2y equals, 24 minus 42. That's going to be 18, negative 18. Divide through by 2. And y is going to be negative 9. So my solution then is going to be 6 comma negative 9. Okay? Now one more type of problem. So this again we need to make either x or y the opposites. So I've got negative 4x plus 9y equals 9. And I've got x minus 3y equals negative 6. For me, the easiest thing I think to do would be to multiply, to change my 9 to the opposite. So I need to multiply this bottom equation by 3, so it's going to be negative 9y and then positive 9y. Does everybody see that? So I'm going to do times positive 3. What I end up with then is going to be 3x. Okay? And then 3 times negative 3 is going to be negative 9y. 3 times negative 6 is going to be negative 18. Now I'm going to bring the top equation down. Then I have negative 4x plus 9y equals 9. And then I add them together, so I'm running out of room. Okay? Let me erase this and work over here. Okay. And when I add them together, let me rewrite them over here. I've got 3x minus 9y equals negative 18. Negative 4x plus 9y equals 9. Okay? Add them. That cancels, it zeroes out. Negative 3x plus negative 3x plus negative 4x is going to be negative 1x. Negative 18 plus 9 is going to be negative 9. I divide through by negative 1, and then x equals 9. I substitute that back into one of the equations. I'll just do the bottom one here. So it's going to be, let's do it up here. X is 9, so I'm going to take 9 minus 3y equals negative 6. Notice I used the original equation before I multiplied it, right? So now I'm going to subtract 9 from both sides. And I end up with negative 3y equals 6 minus 9 is negative 15. And then divide through by negative 3. Y equals 5. So my solution then is 9 comma 5. And that's a solution to that equation. So again, the steps are make either the x's or y's opposites, like we did, add the equations together, solve for x or y, then substitute to find the other variable. All right, we hit pause now.